What's up? John Sonmez from simpleprogrammer.com. So today we're actually going to be talking about a programming topic. Yes, a real programming topic. I'm not even joking here. And I want to talk about composition versus inheritance. I'm not going to use code examples. We're going to talk in the abstract here. But I think that you will find this useful if you've been struggling between when should I use inheritance and when should I use composition and what's the difference and why is one better than the other? Is one better than the other? So let's give a quick recap on the difference between composition and inheritance. I'm going to talk about why I prefer and really recommend composition in most cases. And I'm going to talk a little bit from a sort of a C# Java perspective when I talk about things like classes and interfaces, but this really applies to just about any object-oriented programming language, which is where you'd have composition or inheritance. It's functional languages, we can kind of blur, it's a different paradigm. So, some of this stuff may apply in a very abstract way. But let's talk about, first of all, the obvious one, which is inheritance. What is an inheritance? Inheritance, the book definition is a relationship, right? So I am a man. A man is a animal or a human being, we could say. We could classify. We could say, Ford is a car. We could say a car is an automobile. We could say a plane is a vehicle. So, in that instance, maybe we have a vehicle class, right? And then we have subclasses or child classes, however you want to call it. So underneath the vehicle, we might have an airplane, we might have a car, and we might have a boat, okay? And so the idea with inheritance is that that parent class has some base functionality, so we don't duplicate functionality in all of these things. Because an airplane has an engine maybe, or it could be driven, right? A boat can be driven, a car can be driven. So all of these vehicles can be driven, right? And they might have similar functionality that allows them to drive, even though they drive in different ways. So we could take a vehicle class, we could put all that functionality about how to drive in there that they would share, and then they would all inherit from that. So they'd have that base functionality, and then it'd be a subclass. So a boat would have its own functionality, right? It would have it would maybe override some methods in order to be able to drive on water, and an airplane to handle driving in the air, and a car to drive in the street. And so they would have those differences there that we would subclass. And we could subclass further. We could have different types of airplanes, right? We could have a jet, and we could have a propeller plane, and we could create this whole inheritance hierarchy tree. Now, the thing that we can do with inheritance is that we could, the beauty of it is not just the code that we're sharing, right? That we're not duplicating this code between all these classes that have similar functionality, but we can now treat more specific types, right? The subclasses as the base type if we don't care about the differences. So, for example, we could make a function, or we can make some other class that will work on any vehicle. Let's say we have this car wash class, right? In the car wash class, or not car wash class, let's say vehicle wash class, right? It just takes in a vehicle as a parameter and in one of its functions, in the clean function, and it just cleans the vehicle. It doesn't care if that is a boat or an airplane or a car, right? It's still going to work. So that's inheritance, right? And that's kind of the idea behind inheritance, right? It also lets us do some interesting things that's not exclusive to inheritance, but we can do polymorphism, right? We can basically, override functions, and then on the base class, we can we can call whatever that function is, and then each subclass, right? Our plane, our car, our boat will do something different, like when we call drive, right? So that's the idea. Okay, so now we've got composition. So composition is a relationship, it's a has a relationship, right? And so with composition, what we would say is that something has, and we can sort of apply this in the same context, right? In the same type of situations, because we could say, instead of defining a vehicle class, right? That's the parent class. We could have, you know, the attributes, right? So what does a vehicle do? Well, it's drive. It's a driver, right? A vehicle can be driven. We could say that, you know, we could define what do vehicles have, right? They have the ability to drive, and some of these, right, are not concrete. We could say that vehicles have engines, right? So we could define that functionality. And so with composition, what we would do is we wouldn't have a vehicle class. We'd have our car, we'd have our boat, we'd have our motorcycle, our car, our boat, what I say, an airplane, right? And we would have an engine. It has an engine in each one of those. So we'd define this engine class, and we'd make the engine part of the boat, part of the, I don't know, I'm having so much trouble, part of the boat, part of the car, part of the plane, right? You see what I'm saying? And we'd have maybe a drivable class. We're going to get a little bit into interfaces here, but we could have the driving functionality built into that, right? And maybe that is what has the engine, but we're basically going to componentize it. There's not going to be a hierarchy, but we're just going to define these components and give them to the classes so that they have them, right? That's generally the difference between composition and inheritance. So, as I've sort of alluded to, in a lot of cases, we can actually make a choice. Some things, you know, if you look at the textbook examples of object-oriented programming, and this is where things get confusing, it basically says, well, if it's is a relationship, use a class, or use a class hierarchy, use inheritance. And if it's a has a relationship, then use a composition. And then there's also an implemented in terms of, which we could say composition. But we can actually take a lot of inheritance examples, and we can get rid of inheritance. We could use composition, or we can even sometimes force inheritance when we have compositions. It's sort of flexible on this as a hisa, or as a isa, as a hisa, as a isa. So let's talk about what's the advantage and what's the disadvantage here. So I don't like inheritance, and I'll tell you why. It seems like it seems like the most practical, seems like the most straightforward when you're trying to model the real world. It seems like it makes sense, but here's the problem with it. The problem is that inheritance is never really clean, or very rarely is it very clean, and it's very hard to unwind and get out of. It sort of traps you into these paradigms, especially when you start to get multiple inheritance, and you start to have situations like you've got multiple hierarchies where, let's say that you end up creating a whole class of flying things in let's say you're creating a game or something, right? And so now you've got flyable objects, right? And you've got a plane, okay? And you've got a bird, right? And you've got a flying squirrel, okay? And so now you've got but a plane is a vehicle, right? So it either has to have multiple inheritance, it has to inherit from a vehicle and a flying thing, right? Because you've got functionality, because you don't want to duplicate the functionality. So now you've got these kind of sticky situations where it's like, well, which does it belong in? Does it belong in this hierarchy of flying things, right? So I don't duplicate the functionality of flying. Or does it belong in the vehicle hierarchy? So you end up having these problems with inheritance. Inheritance traps you sort of in these ways, because now you're stuck here, right? Whereas composition, if you use composition instead, what's going to happen is that you're a little bit more flexible. So here's what I recommend to do. And let's take that example. Let's say we had that flying class, and you know, we had things that can fly in our game, and we had this plane, and we have vehicles. What we could do is we could basically take the functionality of a vehicle, and we can have all of that functionality be just a class that the different vehicles have, right? So we could even just straightforward do that. I mean, we might want to break it down and have an engine and have drivable and stuff like that, but we could just have a vehicle class, right? And or vehicle implementation or something like that. You can define it however you want. And you can have a boat have the vehicle class. And then whenever you'd want to call, let's say, drive on the boat, what you would do is you would call drive on its vehicle implementation, right, on the vehicle that it has within itself, which would use the engine, which would do whatever, and it could call out, right? You could pass in an interface or some kind of implementation to that vehicle that defines how that it drives, right? So we can think about it. Sometimes it takes a little bit of thinking to figure this out. And sometimes it's easier to just create the classes and to create the interface and create that class hierarchy. We have to think a little bit more of how we can use composition. And so one way to do that, again, I'm going to talk from a Java and C# perspective here, is that we can use interfaces, right? So instead of creating a class hierarchy where we have a vehicle class and we have a car and a boat and a ship or whatever, an airplane, whatever it is, we can have an interface called iVehicle, or the vehicle interface. And what we can do is we can have a car and a boat and a airplane all implement this iVehicle interface, right? And then, but at the same time, remember, this airplane needed to be a flyable object in our game, right? So we could have an iFlyable interface, and a bird can implement that interface, and the boat can implement that interface, or not the boat, flying boat. The airplane can implement that interface, right? And the flying squirrel can implement that interface. So the airplane in our case would implement two interfaces. It would have the iVehicle interface, and it would also implement the iFlyable interface, right? Now you can see how composition becomes a little bit easier and how that can make sense, because now it just has to implement those interfaces. It has to provide that functionality. But now you say, okay, well, what about code duplication? That's where we can have a default vehicle implementation. So what we would do in that case, remember in the class hierarchy, right? If you're still following me here, when we had a vehicle class that was a parent class, we took all the functionality that was common to all vehicles, and we put that up into the vehicle class, right? And so that's so we didn't duplicate that code. And that was, it handled stuff like driving or using an engine and stuff like that. Whatever you can imagine that is going to be common to the vehicles, where you would have duplicated code in all of those. So when we use an interface, right, and we put the interface on the airplane, and we say iVehicle, now it has to provide an implementation. We still have those methods, the functionality, but there's no implementation. And so the same thing would happen for a car, and the same thing would happen for a boat. And so they'd all have to re-implement that, right, that interface. And now you'd have duplication again. So what you do is you take all of that common code, and instead of making it a parent class, now you have two things. You have this iVehicle interface, okay, that defines what functions that, or what methods that these classes should have. And you've got a vehicle default implementation that provides the common functionality that exists within all of those classes. And then what you do is, inside of the airplane, it implements the iVehicle interface, okay? And the way that it implements that is that it basically just delegates all of the function calls that it can use the default implementation for to its internal vehicle. It has an instance of a vehicle class, right? A vehicle object. It has internally in it with a default vehicle, and then when it goes to implement drive, it can just call the default. Now, if it needs to override something, like we do in an inheritance where we do polymorphism, it simply doesn't delegate to the vehicle object inside it. It just creates its own implementation of it. Okay, so we're getting all the functionality. Now the same thing happens on this other class hierarchy that we would have had, where we have the flyable, right? So now this airplane, it can also implement this flyable interface, and that flyable interface can have a default flyable for the shared code for the birds and flying squirrels and airplanes, right? And it can decide, do I want to override the default implementation for flyable objects in this game? Or do I want to use the default? If I want to use the default, I just delegate to it. When I implement that interface of iFlyable, if there's like a fly method, I just call, flyable default impl, or flyable default dot fly. I return that, right? If I wanted to create my own version of that or override that, use a polymorphic approach, then I can just not delegate. Instead, I still have a flyable object or whatever inside me, but I can just create my own implementation. I can provide my own implementation for that. So that gives you the ultimate amount of flexibility, right? Anything that you can do, right? I'm giving you a formula where you can take anything that you can do in inheritance structure, okay? And you can convert it to composition. And it's it's more flexible, a lot more flexible, because it allows you to have multiple inheritance, essentially the same functionality without the complications. Most programming languages don't allow multiple inheritance. Programming languages like C++ do, and there's a whole problem with multiple inheritance. So you're using interfaces, and you're using composition and delegation. Now, is there a drawback to this? In languages like C# and Java, yes. The one drawback, really, or the major drawback to it, is that what ends up happening in those cases is that you do have to write all this kind of boilerplate delegating code. I've thought about creating a programming language where you automatically have this composition mechanism baked in. In fact, there are probably some languages that have things that they call mix-ins or things like that, where it's almost like doing this for you. But that's the only drawback, is that you do have to have a few more objects that are internal representations for your boat, your car, right? All of these things to have that vehicle implementation. Then when you implement the interface, you have to call the methods on each one of those if you have a lot of default. But this allows you to compose things further. In fact, what I would recommend that you do is that you have a lot of different interfaces, and you have a lot of different sort of default implementations, so you can split the functionality at an even finer grain. Sometimes when you use inheritance, you're not splitting that functionality at a very high grain. So instead of having a vehicle class, you might want to split that up and say, well, what does a vehicle do? What are the kind of things, and you can have multiple interfaces. Don't get too crazy with that, but you can certainly do that. So is that clear? Does that make sense? You see how you could take anything from inheritance and you could redefine this in a way just using interfaces and default implementations and a little bit of delegation to be able to do that. And then the beauty of this now is that you can do the same things that you could do with inheritance, because in inheritance, right? Remember I said we had this vehicle washer, right, class? So this vehicle washer class can still work, right? In inheritance, you passed in the vehicle and it treated it as the parent class, right? And what it did was it called, polymorphically, it called whatever functions it needed to on that vehicle, and it worked for all vehicles, for a boat, for a plane, for a car, right? If you're using composition, you can do the exact same thing. So you can still have that vehicle washer, but now what it takes in as a parameter in one of its methods, or when it gets constructed, is an iVehicle interface, right? Could even be an iWashable interface, but let's just say an iVehicle interface. So now you can still pass in a boat, you can still pass in a car, you can still pass in an airplane, and that all works. But now the beauty is things like airplanes that kind of belong to what would have belonged to two inheritance hierarchies, they can now be used in some other class that works on flyable things, on things that fly, right? So that's the real reason here. So to summarize, my thoughts on this, and hopefully I've made this clear so you understand. Don't use inheritance. Just don't. There's rarely a reason why you should use it, right? Because composition, using interfaces and default implementations, works just as well, if not better, but it gives you more flexibility, right? The inheritance will get you stuck in a situation, and you can refactor just about any inheritance. I can't think of an inheritance situation from what I've described where you couldn't refactor it into composition, like I said, using interfaces, delegation, and default implementation classes, right? Maybe a little bit more boilerplate code, but much more flexible code. So there's really no reason. When people say composition versus inheritance, I say no, just composition. Forget inheritance. It's a bad paradigm. It's a very bad programming methodology that trapped you. I'd rather be more flexible. So I can't think of any really good argument to use inheritance that isn't a straw man argument, that isn't something that you've come up with just specifically, right? I mean, maybe there'll be some occasion, but let's just say 99% of the time, for the sake of not using extremes and absolute, let's say 99% of the time, use composition. Use it whenever you can. And maybe that 1% of the time where inheritance is the only thing possible, I can't think of it right now, then you would use inheritance. So, hopefully that's clear. No code, but I tried to explain it here. If you're not familiar with object-oriented concepts, if you don't know inheritance and composition, if you haven't done a lot of object-oriented programming, you're of course not going to follow this if you don't know what polymorphism is, So don't be too freaked out. But if you go and you try this with the example, just go through the example code. If you're a new programmer, go through the example that I just laid out and make those classes and see how you could do this, right? And experiment with this. And if you really want to grasp this, right? If you are an experienced programmer or somewhat experienced, go and try this. Take classes, right? Take inheritance situations, classic ones from textbooks, right? Or from examples, and rewrite them into composition so you get good at this and you understand how to do this. Once you develop this skill, this is an extremely valuable skill, especially if you're, like I said, a C# or Java programmer. It applies beyond that. But there's ways to do it in JavaScript as well. I'm not as well versed in that, so I'm not going to try and explain to you how to do that in JavaScript. But try it, practice it, get good at it. Once you get good at this, this is extremely valuable. Anyway, I hope you liked this video. If you did, I have a request for you. Click the subscribe button below and you will be subscribed. I do about 2 to 3 videos a day. Most of them are not highly technical. I'll warn you right now, I do a lot of personal development and self-development because that's my passion, because I feel like software developers need to know more in life than how to write good code and how to be technically competent. And there's not a lot of people doing that. So click the subscribe button and you'll see some of my crazy videos. And if you like this video, give it a thumbs up. If you've got some ideas on composition and inheritance, I'd love to hear them. Leave a comment below and I will talk to you next time. Take care.